Hi guys. We are starting, I think this is actually probably going to be the last chapter for the entire school year, if you guys can believe it. Brand new chapter, brand new topics. We are going all the way back to chapter 5 to talk more about solving systems of equations. This kind of goes back into, if you guys remember, I think this might have been like in January or so when we would graph two lines in a coordinate plane and they would intersect at a certain point, and that point that they intersect would be the answer to the question. That is the idea of a system of equations, but the next couple sections that we do over pretty much the rest of the school year actually are talking about, or are going to talk about, different algebraic methods to solve these systems of equations. All right, so the first method that we're going to talk about, as you guys can see, it's called substitution. There are two different methods to solving systems of equations algebraically. This substitution specifically is coming from section 5.2 if you still use the textbook. What does this say here? So yeah, one of the methods is substitution. The ultimate goal, like what you're going to see in a little bit, what these kinds of problems are going to look like is you're going to have two different equations in two different variables. All right, so it's usually in terms of x and y, and the ultimate goal, that what it says here, when you're solving a system, regardless of whether you're using substitution or the other method, which is called elimination, is to somehow rework the two equations so that you have one equation in one variable, like just x or just y, so that you can then solve it. So specifically when we talk about substitution, like I said, you're given two different equations. So the first step would be to solve either one of those two equations for either one of the variables, x or y. It doesn't matter which equation you use. It doesn't matter which equation you solve for, which variable you solve for. It's whichever's easier. All right? So then you would substitute that equation into the other equation for that given variable, simplify, solve, get the value of the first variable, and then plug that value back into either original equation and then solve for the other variable. And since it does go all the way back to an intersection point, you are going to have to write the values as an ordered pair, x comma y. So I totally understand if none of that made any sense to you. So I think it might just make more sense if we actually work with a problem. So we have these two equations, right? And the very first step in solving by substitution is to solve either one of these equations for either x or y. It doesn't matter. Now, the nice thing about this problem, I think this is one of the easiest types of problems that you're going to see because you already have both y equals. All right, y equals y equals. Y is by itself in both equations. So that part of the problem is already taken care of for us. All right. So like if I focus on this first equation where y is equal to 3x, I'm going to take this expression, 3x, and substitute it in to the other equation wherever I see a y, because y is equal to 3x. All right? So the equation then is going to look like this. All right? And then it's just a normal equation that you can solve the same way we have been since the beginning of the year. Get all the variables over to one side and divide by 2. So x is equal to -1. Now the thing is, because you're getting two values to make an ordered pair, once you get a value for x, you're not done. You have to figure out what y is as well. So you can take this -1 and plug it into, I would go back into the original equations, either one. It doesn't matter. Whichever of these equations you pick to plug -1 into, you should get the exact same thing regardless if you did this right. So I'm going to pick the first one. Again, it doesn't matter. And I'm going to say y is equal to 3 times -1. So y is equal to -3. So there's my x, there's my y, which means my ordered pair is -1 comma -3. And that is the answer to the system, or the solution to the system. Okay. Actually, before I forget, I think we might have done stuff like this before. It doesn't say check your answer, but if a question like this did say check your answer, it would be the same kind of thing you've always done. You would have to take both the x and the y, plug them back into both of these equations, and you should get true statements for both. But since it doesn't say check your answer, we're not going to bother with that. And we're going to move right along to the second one. So this one, again, is some of the work is already done for us because we already have y equals. All right, we already have one of these equations already solved for one of the variables. So we don't need to do any work. I'm going to take this x plus 1 and substitute it in for y. So this becomes 4x plus, again, we're replacing y with this entire expression. So this becomes x plus 1. And then we're going to do the same exact thing. Combine like terms. Minus 1. Divide by 5. And again, the problem isn't done yet once you get a value for x or a value for y, or once you solve one of these equations. You still need the other variable. So we're going to plug 1 in to either one of the original two equations. Again, it doesn't matter which one. I'll go with the first one again, just because it looks a little bit easier. Y is equal to 1 plus 1, so y is equal to 2. Again, because it is going all the way back to the intersection of lines, write it as an ordered pair. 1, 2. Okay. This is more so what the systems look like and why the order of the steps is written the way it is. All right, if you take a look at these two equations, we don't have either one of these two equations already solved for one of the variables. So we're going to have to do that extra work. All right, so we're going to pick one of these equations, pick a variable, and solve that equation for that given variable. Now, how do you know what to pick? All right. Well, technically, I mean, the grand scheme of things, it really doesn't matter, all right? But if you have any, like, plain old x's or plain old y's, I would say, if you don't have any coefficients in front of any of the variables or in front of some of the variables, I would say pick one of those variables to solve for, because then you're not going to have to worry about dividing anything, and then there's absolutely no chance that you're going to get any fractions. So what I mean by that with this problem is like these two x's, right? Both of the x's do not have a coefficient in front. There's an invisible positive 1. So solving either one of these is going to be pretty easy, all right? Solving either one of these for x. I'm going to pick the second one to solve for x, because how would I solve this equation for x? Well, I would have to move the y over to the other side, which means I would have to add y to both sides. All right, you would still have to do all the inverse operations. And the reason why I picked that is because that's going to get us x alone, and it's also going to get us y plus 5. You wouldn't be able to combine any of those because they're not like terms. All right. Everything in here is positive. There's no weird negatives that we would have to worry about. If you're able to notice something like that right away, I would definitely, do something like that. But like I was saying, in the grand scheme of things, it really doesn't matter which equation you solve for and which variable you solve for. As you can see, there are certain situations where solving one equation for one variable over another one is going to make your life a whole lot easier. Like if we had solved this first equation for y, we would have had to divide everything by 2 at some point, which means the -1 would have had to be divided by 2, and that would get us 1/2, which means we would have to deal with fractions, and nobody really wants to deal with fractions. All right, so that's the only additional thing that we have to do that we haven't done in another problem up to this point. So we have x equals, and now we're going to take this expression y plus 5, and we're going to go back to the original two equations. This was the one we solved for. So we're going to take that y plus 5 and plug it into the other equation. It is really, really important that you do plug it into the other equation, because if you plug it back into the same equation that you worked with originally, things are going to start canceling out and it's going to be weird and it's not going to work right. So you're going to plug this in for x in the other equation, the one you haven't dealt with yet. So we replace x with y plus 5. So y plus 5 plus 2y equals -1. And then it's the exact same thing as the last problem. So 3y plus 5 is -1 minus 5. All right. So we have our y value, but we don't have our x value. All right, so again, we're going to have to plug this -2 back into, I would stick with the original two equations, just in case, you know, if you solved this wrong and you plug this back into here, it's going to mess up your x value as well. So I would stay consistent and plug this -2 back into one of the two original equations. Again, I'm going to go with this one just because the numbers look a little bit nicer to me. It doesn't matter. Again, you should get the exact same thing. So this is going to be x minus -2 is 5. So this becomes x plus 2, and x is 3. So again, the ordered pair is going to be x comma y, so 3 comma -2. Okay? Sometimes you substitute an expression for a variable that has a coefficient. When solving for the second variable in this situation, you can use the distributive property. I think that's pretty much self-explanatory, and I think there will be some problems like that, maybe in a little bit. When you solve one equation for a variable, you must substitute the value or expression into the other original equation, not the one that had just been solved. That's what I was just saying. So this is kind of like what a couple slides ago was talking about with the distributive property. So I'm still going back to that whole idea of if there is a variable that does not have a coefficient, that equation and that variable is probably going to be the easiest to solve for. So that's this first equation, y plus 6x equals 11. The y doesn't have a coefficient. So this first one is the one that we're going to solve for y. So y plus 6x equals 11. You minus 6x from both sides to get the y alone. And we can't combine these again, so this is going to be -6x plus 11. All right? Now we're going to take this expression, -6x plus 11, go to the other equation, and substitute it in for y. That's why it's called substitution, because you're solving and then substituting and then solving again. So this becomes 3x plus 2 times the entire expression. That's where the whole distributive property is going to come in. So this is -6x plus 11 equals -5. So the 2 gets distributed. 3x minus 12x plus 22. -9x plus 22. Minus 22. So x is 3. And now we have to keep going and plug this into either one of these equations to figure out what y is. I think I'm again going to go with the first one. Again, it really doesn't matter. So y plus 6 times 3 is 11. This is y plus 18. So this is -7, I believe. Yeah. And then to finish it off, we write it as an ordered pair. Okay? All right, let's do one more. Just to kind of make sure we're solid and everything, because I feel like stuff like this, unless you would have to divide something by an actual coefficient, I think this is the hardest it's going to get. So again, this first equation for y, there's no coefficient on the y. So I'm going to solve this first equation for y because I think it's going to be the easiest. All right. So this is negative 2x plus y equals 8. You would add 2x to both sides. So y equals 2x plus 8. This is going to go into the second equation for y. Yeah, for y. So 3x plus 2 times the entire 2x plus 8. 3x plus 4x plus 16. This is 7x plus 16 minus 16. This is negative 7, divide by 7, and x is negative 1. And now once again, we're going to, let me rewrite that because that doesn't look right. Negative 1, there we go. And now we're going to take this and plug it into either one of these two equations. Again, I'm going to go with the first one just because the numbers look a little bit nicer. Negative 2 times negative 1 plus y is 8. This is 2. And this is 6. So your final ordered pair is negative 1, comma 6. Okay? Let me see what else is. Let's see. This looks kind of similar. I think a lot of the rest of these problems are very similar to ones, yeah, that we've already talked about. So I'm gonna, again, do these off camera. You'll have the answer keys digitally for you guys to look at. And you guys know where to find me if you have any questions. The thing is, with these kinds of problems and with systems in general, regardless of, like, even when we do end up talking about the other method in a few days, there's a lot of work that goes into both types of methods. So when you do your assignments, I am going to be looking for you showing your work. It's up to you if you want to type it all out. I know some of you guys have been doing that, or taking pictures, like doing it in your notebook and then taking a picture of it. That's fine too. As long as you show all your work, I'm really going to be looking for that for this unit. All right. And please also, just in general, make sure if you're taking pictures in your notebook, make sure it's really clear. I've had a lot of, like, there have been a couple people who have been taking pictures in their notebook and they've been kind of blurry. So please make sure I am able to, like, somebody else would be able to read your work when you take a picture of it before you submit it. And I think that is everything I have to say for now. So stay safe, and I'll talk to you guys soon.